For most interstellar visitors, their arrival is flagged early months, sometimes even years in advance. Our telescopes, increasingly sharp and far-reaching, are trained to catch objects entering the solar system from all directions. But 3I, Atlas, didn't follow that script. It slipped in unnoticed, breaching the perimeter with surprising stealth. It wasn't until it was already alarmingly close that anyone realized something foreign had arrived. That fact alone has sparked debate. Why did it go undetected for so long? The answer lies in where it came from. The object approached from a segment of the sky that is notoriously difficult to monitor an observational blind spot. Even the most advanced space surveillance systems have limitations when it comes to coverage near the sun's glare or in regions lacking dense observational arrays. 3I, Atlas, exploited that very weakness, arriving through the least watched corner of our cosmic backyard. And then there's its glow. By the time astronomers laid eyes on it, the object already resembled a bright, glowing comet, visually speaking. That initial image might have settled the matter for casual observers, but it didn't settle anything for the astrophysicists who knew better. This wasn't just about brightness, it was about timing, geometry, and behavior. Objects of interstellar origin typically announce themselves with a clear trajectory and a long arc of approach, allowing scientists to track their journey from deep space. But not this one. The detection came late, and the path it took raised more questions than answers. A few researchers quickly pointed out that its entry into the solar system bore unusual hallmarks, starting with the very fact that it wasn't spotted until it was practically at our doorstep. And then the comparisons began. Oumuamua, the first known interstellar object, discovered in the year 2017, had triggered similar uncertainty. But at least it had been detected while still outbound, giving scientists a brief window to scramble for data. With 3I, Atlas, there was no such grace period. It had already passed several key waypoints in the inner solar system before telescopes even registered its presence. What emerged wasn't merely a late arrival. It was an anomaly that seemed to understand where our attention wasn't. That sent a ripple of unease through certain parts of the astrophysical community. It was the first of many signs that this object, whatever it is, might not be following the rules of natural randomness. Trajectory tells stories. And in the case of 3I, Atlas, the trajectory speaks volumes, just not in the language of natural coincidence. Most interstellar objects enter our solar system on wildly random inclinations, cutting across planetary planes at odd angles. But not this one. 3I. Atlas glides through space in near-perfect alignment with the ecliptic, the flat plane in which all major planets orbit the sun. That's no small detail. In fact, it's nearly impossible to overstate how statistically improbable that is. Calculations suggest the odds of such alignment happening by chance are roughly 0.2%. That's not just rare, it's astronomically suspicious. And it doesn't stop there. Its path brought it within unusually close proximity to not just one or two, but three of the solar system's most Earth-adjacent planets: Venus, Mars, and Jupiter. The likelihood of an interstellar object passing close to all three in one sweep? About 0.005%. Again, not random. That level of alignment begins to take on the qualities of intentionality. The path resembles something eerily familiar to NASA engineers: a gravity assist route designed to utilize the gravitational pull of multiple planetary bodies. It's the same logic used in the flight paths of the Voyager and Cassini spacecrafts. Such slingshot trajectories are no accident. They are the product of precise calculations down to fractions of a degree. If 3I, Atlas, had merely drifted in from deep space, we would expect it to tumble in from some awkward, meaningless angle. Instead, it appears to chart a course optimized for planetary encounters, maximizing proximity to key solar system bodies without any abrupt, chaotic shifts in motion. And that's deeply unsettling. Then there's the kicker. Its perihelion, the closest point to the sun, occurs when Earth will be on the exact opposite side of the solar disk, which means, at the critical moment of its closest solar approach, the object will be completely obscured from all direct observation on Earth. The sun itself will block our line of sight. The probability of that alignment? Around 7%, still low enough to raise eyebrows. This kind of trajectory, low inclination, multi-planet proximity, timed Earth-blind perihelion is not the profile of a cosmic drifter. It's more like a reconnaissance run. The route would offer optimal data-gathering potential while minimizing the risk of detection. And while most scientists hesitate to suggest anything beyond statistical anomalies, a growing number are starting to whisper the words that were once taboo. Maybe this thing is flying itself. No one's claiming alien spacecraft outright. Not yet. But the geometry of the journey is undeniably peculiar. And geometry, in space, doesn't lie. If trajectory raises suspicion, then the object's physical behavior all but demands it. The first sign something was off came when astronomers realized 3I. Atlas wasn't shedding material like a normal comet. Typically, when an icy body approaches the sun, the rising heat triggers sublimation. Solid ice turns to gas, forming a glowing tail of dust and vapor. It's Comet Science 101. But 3I, Atlas refused to cooperate. Despite being in a zone of intense solar radiation, no outgassing was observed. No dust, no tail, no trace of cometary evaporation. Just a steady, compact glow, far too smooth, far too quiet. The object behaved less like a frozen relic and more like a sealed shell. That absence of a tail puzzled astronomers, because it wasn't just unexpected, it was inconsistent with the object's apparent brightness. It glowed like a comet. It didn't act like one. Some researchers hoped spectroscopy would bring clarity. By examining the wavelengths of light reflected and emitted from the object, scientists can deduce its composition. And indeed, one reading detected what appeared to be a water-ice spectrum, an initial relief for those advocating a natural origin. But deeper analysis disrupted that comfort. The signal didn't match. Where the model predicted peaks, the data showed troughs. Where it expected dips, there were rises. The spectral fingerprint failed to align with expectations. That's not how water should behave under such conditions. The mismatch suggested one of two things. Either the surface of 3I, Atlas, holds unknown materials that are interfering with the reading, or the signal is being masked, perhaps by design. Then came the size estimates. Avi Loeb's team originally pegged it between 12 and 20 kilometers wide based on its luminosity. Later, with refined observation, the consensus landed around 12 kilometers, exactly within Loeb's early estimate. That consistency bolstered the credibility of his other claims, which had been met with resistance from mainstream astronomers. What added an eerie final touch was the object's age. Based on its spectral profile and trajectory, researchers estimate 3I, Atlas, is at least 7 billion years old, predating the Sun, Earth, and the rest of the solar system by over 2 billion years. That means this object was already ancient when the planets were just dust in a disk. It's a traveler from a time before the sun was even burning. To summarize, no tail, flawed water spectrum, oddly compact brightness, precise sizing, and an age that spans epochs beyond comprehension. If 3I, Atlas, is a comet, it's a comet like no other. But if it isn't, then the list of alternatives becomes extremely short and deeply provocative. The astrophysics community is no stranger to disagreement, but few debates have divided it as sharply as the ongoing discourse around 3I, Atlas. At the center of the storm stands Professor Avi Loeb, a Harvard astrophysicist known for courting controversy and refusing to dismiss the improbable. His voice, once sidelined during the 2017 Oumuamua encounter, now echoes louder this time, with a chance to intervene before the object vanishes into deep space. Loeb argues that 3I, Atlas, may not be natural. He does not shout aliens. He doesn't need to. Instead, he systematically builds a case based on data, not drama. The trajectory too clean, the timing too precise, the silence too unnatural. These are his pillars. And once again, many of his peers recoil. Mainstream astronomers counter with dismissive logic. Correlation is not causation. A rare trajectory can still be random. An absence of outgassing doesn't prove artificiality. The lack of tail could be due to composition. Maybe 3I, Atlas, is simply made of less volatile material. Maybe it's covered in dust that suppresses sublimation. Maybe. Their stance is driven by a desire for scientific conservatism, better to err on the side of known physics than drift into the gravity well of speculation. But even these cautious voices concede one point. 3I, Atlas is weird. And that brings us back to 2017. Oumuamua, the cigar-shaped enigma, was the first confirmed interstellar object to pass through our solar system. It too defied expectations. It accelerated without a tail. Its spin made no sense, but scientists, strapped for time and unable to follow it for long, wrote it off. By the time questions rose, the object was gone too far, too fast, too late. Loeb had warned then. He had called out the missed opportunity, arguing that our instruments and institutions weren't ready to consider alternatives outside the framework of rocky bodies and icy debris. That failure haunted him. With 3I, Atlas, he sees a second chance. The community, however, remains hesitant, funding telescopes, reorienting satellites, committing media attention. It's a lot to ask for an object still labeled probably a comet. Loeb's insistence feels, to some, like déjà vu laced with desperation. Yet the data continues to drip in, and each drop chips away at certainty. The division isn't just academic anymore, it's generational. A younger wave of scientists, raised in a universe where exoplanets are common and fast radio bursts are real, are less allergic to extraordinary explanations. They don't seek aliens, but they don't reflexively reject them either. Still, the clock ticks. 3I, Atlas is on a sunbound path. The window to study it narrows with each passing day. The question now is whether the scientific establishment will move fast enough, or once again let the unknown slip through its fingers, unnoticed until it's just a footnote in a lost opportunity. There's a moment when statistical anomaly tips into something else, an eerie alignment of variables that no longer feels accidental. That's where 3I, Atlas, now stands, at the intersection of astrophysics and paranoia. And if the object is more than just a cosmic rock, then the implications fall squarely within one of the most unsettling theories in modern astrobiology, the dark forest hypothesis. This theory, grim and logical, suggests that the universe is teeming with intelligent civilizations, but none of them are talking, because to speak is to be seen, and to be seen is to risk destruction. In this view, space isn't a silent void. It's a forest filled with hunters, each hiding in the shadows, terrified of attracting the attention of something stronger. Now take 3I, Atlas, an object that arrives undetected, enters on a plane matching planetary orbits, glides past multiple key worlds, avoids Earth's view at its closest solar approach, remains eerily silent, no tail, no dust, no data leakage. And behind that glowing disguise, it might be something else. What if it's not a comet at all? What if it's a surveillance probe? A disguised scout wrapped in comet-like emissions to fool optical detection systems? What if the trajectory wasn't a coincidence but a mission path, an interstellar flyby to gather information from multiple planets, including Earth, without triggering alarms? The timing would be perfect. Humanity's instruments are advanced but fragmented. Our surveillance systems are numerous but decentralized. A sufficiently clever path could avoid them all, especially if designed to exploit blind spots, like approaching from a hard-to-monitor patch of sky, like hiding behind the sun at perihelion. It's stealth, not invasion. And that's what makes it terrifying. The dark forest hypothesis doesn't demand malevolence. It simply suggests fear. Civilizations stay quiet not because they are evil, but because they are rational. They don't shout into the void. They listen. They observe. And when they act, they do so silently. 3I, Atlas checks too many boxes. That doesn't mean it's alien. But if a civilization were to send something across interstellar space to peek into another system, this is how they'd do it. Small, cold, slow, disguised. It wouldn't communicate. It wouldn't land. It wouldn't reveal itself. It would pass, gather, vanish. And if we were being watched, we wouldn't know until it was already too far away. In 2017, the object known as Oumuamua slipped through the solar system and exited before we could even ask the right questions. Its anomaly's unexplained acceleration, the absence of a tail, a shape unlike anything we had seen were dismissed with little more than academic shrugs. The window had closed before anyone took it seriously. It was a missed opportunity, a ghost of what might have been. Now, with 3i, Atlas, that window is open again, but not for long. The object is already nearing perihelion, and soon, observational geometry will shift beyond our favor. The chance to scrutinize it up close is vanishing with every revolution of Earth. What's different this time is not just the object, it's us. We know better now. We've seen how easily something extraordinary can be rationalized into nothingness, buried under technical jargon and institutional inertia. This isn't about aliens. It never was. It's about curiosity, the drive to understand what we don't yet grasp, the humility to say, this looks wrong, the willingness to look again. The danger isn't that 3i, Atlas, is a spacecraft. The danger is that it might be something unprecedented, and we turn away out of fear of being wrong. If the object is artificial, ignoring it would be the greatest scientific failure of the century. But even if it's natural, it could still be something we've never encountered before, a new class of interstellar body, an ancient relic older than our sun, a physics defying mystery waiting to be solved. This is the moment to lean in, not pull back, to allocate the sensors, mobilize the telescopes, issue the proposals, and prepare for the possibility that the universe just whispered to us again. Because if we miss this chance, there might not be another.